Hi, we're going to continue now with section 12.3, which is on rotations. Rotations are a type of transformation. They are, in layman's term, we turn the pre-image onto the image. A rotation is considered to be an isometry. The shape the pre-image maps to the image. It's the same shape and size, so that's what makes it an isometry. It has the same orientation. If I take a look at my pre-image here, ABC, I'm going around in a clockwise manner. To name the image, ABC prime, I'm still going around in that same clockwise rotation, so it has the same orientation. The point at which it rotates about is referred to as the center of rotation. So moving on to the next page now, in your notes. Sorry about that. So you can take a look and read the definition. Here, it talks about the point being the center of rotation, and that its image are the same distance from P, such that all angles with the vertex P formed by the point in its image are congruent. So angle APA prime is the angle of rotation. So, for example, if this appears to be a 90-degree rotation, we will always rotate counterclockwise so that everyone is rotating in the same manner. In order to construct a rotation freehand, you're going to need both a protractor and I like to use a compass. Some people don't feel the need to bother with it. And we're going to do this activity in class, but just to kind of give you an idea or a flavor of how we go about doing a rotation freehand, is that this is the center of rotation. We draw a line segment from the vertex to that center of rotation. Then we take our protractor, and in this case, let's say I want to do a 60-degree rotation. I would find my protractor markings. In this case, I'm using the outer edge, and I'd mark off 60 degrees. I would draw a ray, and here is my 60-degree rotation, right here. Now, in order to do the proper mapping, that's when I use my compass, and I measure the distance from the center to the vertex point. I hold that position, and then I just mark it off on my ray, and that's where A prime would be. I would continue to do this same process. I would connect a line segment from C to Q, mark off from C to Q, and then mark off 60 degrees with my protractor, draw that ray, and then again use my compass. But we're going to do this in class so that everyone can see how it's done step by step. The rest of the directions here are going to deal with doing rotations on a coordinate grid and what are the guidelines for those rotations. So if you move to the next page, please. So two very common rotations in a coordinate plane are 90 degrees and 180 degrees. This is specifically about the origin. So the origin is, let's say, the point of rotation. And so the mapping of P to P prime, xy becomes negative yx. So if I had the point 3, 2, and I want to map it to P prime with a 90-degree rotation, this would become, what do you think? Hopefully everyone says that P prime is negative 2, 3. For 180, so here's my rule right down here. xy becomes negative yx. For the next one, it's 180 degrees. Again, remember, we're going counterclockwise. And so here, xy maps to negative x, negative y. It's going to kind of go to the opposite quadrant. So here, if I have the point 4, 1, this is going to become negative 4, negative 1. So these are two rules that you're going to have to know, but there are others as well that we're going to talk about in a moment. What I'd like you to do right now is put the video on pause and see if you can do this rotation on the coordinate grid. You're going to have to graph triangle JKL with the given vertices and rotate it 180 degrees about the origin. Again, remember that the rule is XY maps to negative X, negative Y. So put the video on pause and do this rotation. So hopefully yours looks like mine, and you have all your proper notations. Now, again, as I said, that we had 90 degrees and 180 degrees counterclockwise about the origin, but you might also be asked to do other rotations. So I just want to go over those rules with you. If you take a look at the bottom of your page here. So if I say something about 90 degrees clockwise, the rule is going to be XY maps to Y negative X. So think about this for a second. Negative 5, 2 would map to what? Figure that out. And I hope you get your answer of 2, positive 5. The next one, 270 counterclockwise, is the same or equivalent to 90 degrees counterclockwise. Oh, sorry, I messed that up. It's 90 degrees clockwise. Sorry, my bad. Clockwise. So XY is going to be the same as the one we just had. Y negative X. And so negative 5, 2 is going to map to, what do you think? The same thing, 2, 5. And the next one, 270 clockwise, think about this. If, let's say my point is here, if I'm going 270 degrees, this would be 180, so 270 would be up here, would be the same as going 90 degrees counterclockwise. So 270 clockwise is the same as 90 degrees counterclockwise. So 90 degrees counterclockwise, if you read above at the top of the page, XY maps to what? Hopefully you have negative Y, X. So my point would be negative 5, 2 maps to negative 2, negative 5. Okay, so part of our homework tonight is going to be to complete numbers 7 to 17 on this is page 13. So I just wanted to go over a couple of them to make sure that you had an understanding of how to do it. Because you don't have any color coding, this is blue, this is black. We're supposed to map black onto blue. And so how we do this is I pick one vertex and I try to figure out, again, this is just an approximation, don't worry about it. Normally if we were in school you'd have a protractor. But what do you think the degree is to go from this vertex to this vertex that it maps onto? So what is, this is the center of rotation, so what is this degree measurement? Hopefully you all said somewhere around 110 degrees. So the next problem here, we're going to do the same thing. Again, we're going to map point P to P prime, but again, remember you're going counterclockwise. So you know at the beginning of the year I said that we'll never deal with an angle more than 180 degrees. Well, this is the exception, because we can go or rotate the figure around in a circular manner to a total of 360 degrees possibly. So my question to you is, what would be the degree of rotation? Here's point C. So what would be the degree of rotation that I'm going to go from here all the way over to P prime? So see what you think about how many degrees you think that that would be. And if you said somewhere around 290 degrees, that would be correct. So try to figure out C for yourself. Numbers 10 through 17, we're going to rotate certain points about the center of rotation. Right here is O. And if you notice, can you figure out what is the degree measurement in between each of these angles here? So hopefully you figured out that it was 30 degrees. So for the first problem, if I want to go 120 degree rotation of B about point O, to go from B counterclockwise to H, how many degrees would that be? So 30, 60, 90, 120 degrees. So we would end up at H. So your answer here is H. So now if I do 60 degree rotation of E about point O, where's E? Let's find E. E is right here. And I want to go 60 degrees. So that's going to be 2 stops, and I'm going to end up at C. So my answer is C. So that's how you go about doing those. So you're going to finish the rest of these for homework. And then finally on the last page, the next page that you're going to do for homework, these are just graphing the pre-image to the image. Again, you're going to use the rules for rotation that are on the previous page that we discussed and see how you can do with those. So have fun with rotations, and we'll do the one with the protractor and compass in class.